My name is Kainton Dejanius, and today we are going to continue with machine learning and data science in Python and R. And today we are going to be taking module 4 together with practical 3. I'm sure by now you have this course outline. So this course outline shows the color coding for the combination of module and practical. So module 4 will be going with practical 3. So you can see this is where we are at this point. So module 4 has to do with supervised and unsupervised learning, classes of subdivisions of machine learning. We are going to be doing the practical about how to acquire data of the online data sets you can use, how to import tabular data from Excel or CSV into Python, export data from Python to spreadsheet, and also getting some free data sites from R. So that is what the practical is going to be all about. So let's go ahead to discuss a few theoretical background of classes of machine learning problems, then we go into the practical. Feel free to let me know if you have some challenges or if you have recommendations following along. So this is the content of today's lectures. We are going to be talking about supervised learning. Of course, this outline here or content says everything like in summary. So under supervised learning, we have classification and regression. Under semi-supervised learning, we have reinforcement learning. Then we have unsupervised learning. Then we have clustering, dimensionality reduction, and then we have density estimation. Under clustering, we have either agglomerative clustering or divisive clustering. We are going to be talking about this a bit later in this course. So clustering, we have two common types or two popular types of clustering approaches, like the k-means clustering and the k-nearest neighbor. They are related, but they are totally different things altogether. And we are going to also be talking about a bit about overview of what neural network is all about. If you are talking about machine learning, you also need to understand the concept of neural network. Then we talk about deep learning, as that has been the interest in deep learning has been increasing in recent years. Then we now discuss what actually is the difference between data science and machine learning. So let's get started with the first one. Here I prepared this chart or this organogram or chart or this hierarchy that shows all different aspects of machine learning. Now, this may not be comprehensive. It may contain a few more subdivisions, but it's better you understand. For now, these are the basic things you need to know. Machine learning, of course, is under AI, and machine learning is divided into three parts: supervised learning, unsupervised learning, then we also have semi-supervised learning. Also mentioned that supervised learning, we have classification and regression, and under unsupervised, we have clustering, dimensionality reduction, and density estimation. Let's now dig a little deep into each of these divisions of machine learning to understand what they are really all about. The reason it's necessary for us to know it is that when we encounter a problem, we'll be able to know what class of problem it is, and that will help us to choose the right algorithm to apply to solve this problem. So let's start with supervised learning. Now, applications where the training data comprises of examples of input vectors along with their corresponding output target vectors are called supervised learning. Now, in the next slide, I'm going to demonstrate what we mean by target vector and also the training data set. For instance, in case of the digit recognition problem we discussed previously, the aim is to assign each of the input vector of a series of pixels to one of finite number of 0 to 9 digits. That is classification. So you have series of input vectors representing an image, and you need to classify it. Is this a 0? Is this a 1? Is this a 2? So that is classification, example of classification problem. But if the output consists of one or more continuous variables, then the task is called regression. For instance, you want to estimate certain figures of the population at some point in time in future. You are talking about regression problem. This will become clearer again as we move. Let's take an example of regression to be, we are going to predict the yield in a chemical manufacturing process where the input consists of concentrations of reactants, the temperature and the pressure, and you need to predict the yield or the output. Okay, so in this case the yield is continuous variable, can be 1.3, it can be 10.56, it's continuous, is a complete infinite number of values that can be there. But when it's categorical, in this case of classification, is either 0 or it is 1 or it is 2. There can be 0.1, there can be 2.5. So it's just categorical. We have 10 categories. That will be regression. That will be classification, I mean. So take some time to spend reading and understand exactly the difference between classification and regression. Now I'm going to do a demo. I'm going to open the IRIS dataset, and then let's see exactly what classification problem is looks like, or what supervised learning and unsupervised learning looks like. So I'm going to open Jupyter Notebook. I'm going to go to my system, and I'm going to open Jupyter Notebook. So okay, it takes a while to open, but that is fine. So I'm going to display a particular data set, and I'm going to explain why we say this data set can be used for classification problem. So I'm just going to start a new notebook. So I'm going to say Python 3. So to import a data set, normally I'm going to say import pandas as pd. And now let me import a data set from my local system. So I'm going to call it dataset is equal to pd.read underscore csv, and then you specify the location of the data set. For me, it's in my drive D, data iris.csv. So let's see, I'm going to run it. So it seems it imported. So let me take a look at what this data set is all about. Data sets. Alright, so you can see this is a data set we've imported into Python, located in my drives D. Now, what you see here is that we have sepal width, sepal length, petal width, and petal length. This is a particular flower, and based on the width and length of the sepals and petals, we classify it into a category. In this case, we have the name can either be Iris setosa, it can also be Iris virginica, and we also have another one in between, Iris setosa virginica, and we have another one. So for instance, if I select data sets, I think I should be able to iLog. Now I'm going to explain all this a little later. iLog, I'm taking the rows. Let me check if row 100, let's say 80 to 100. So I'm taking row 80 to 100. Let's see. All right, so you can see Iris versicolor. So we have Iris versicolor, Iris virginica, and Iris setosa. Only 3 categories. In this case, we are dealing with a classification problem, and we're also dealing with supervised learning. Because we are taking these features, we have these features, length and width for petal and sepal. These are the features. And we take them and assign either to a versicolor or to virginica or to setosa, right? So that is how a classification problem works. Alright, so this is just a little demo I say I'm going to do. Later on, we are going to go in depth into how to work with data in Python. So let's proceed. Unsupervised learning, in this case, we have the training data consists of a set of input vectors without corresponding values. So assuming we have just series of sepal width, length, petal width, and petal length, and we don't have any class they belong, we only have the features of this flower, because it is a flower. If you only have the features without having any category assigned, then we are talking about unsupervised learning. And for sure, you will know that unsupervised learning is a bit more difficult or more tasking to work with, because you don't you tend to be flying blind. You don't know what to do with data because there is no category. You simply have to make sense out of this data. So the goal of unsupervised learning is to analyze this data, look at this data and discover, are there some groups of data that share something in common? In this case, you are going to cluster these groups into a particular cluster, and that is a problem of clustering. You need to check data with similar characteristics and cluster them together and detect data with similar characteristics and create different clusters or groupings of this data. Another thing you can do in unsupervised learning is to determine the distribution of data within the input space. So you are looking at this data and trying to find out where is this data coming from, what is the population, where this sample is drawn, how is the population like. In this case, we are talking about density estimation. Another thing you can also do is that you can take this data and it's high dimensional data, you can reduce it to lower dimension. For instance, if I go back to my example, we have sepal width, sepal length. We can say this is 4 dimension at this point. Can we reduce it to 2 dimension? Actually, I'm going to try to read another data set that is a little larger than this one. So let me try to read another data set. Data set 2 is equal to pd.read underscore CSV. I think I should have the data in drive D data slash wine.csv. Let me see. I think okay, so the data does not exist. So let me try. I think it should be others wine.csv. Okay, perfect. So there is this data set that contains wine attributes or several categories of wine. I want to show you that this data actually has several dimensions or several features that, if necessary, might need to be reduced to be able to visualize this data set. So if I go to data set 2, let's see what is in there. So you can see that it has several features, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So several features there. So is it possible we can reduce it to maybe only 2 or 3 features? In that way, we'll be able to plot it in a graph. So this is about unsupervised learning, and we are talking about clustering, dimensionality reduction, and density estimation. Now we have this concept of semi-supervised learning, which is also reinforcement learning comes under it. So what is it all about? Now each time, think of the kind of data set you are going to be using. In case of reinforcement learning, is concerned with the problem of finding suitable actions to take in a given situation in order to maximize the reward. So in contrast to supervised learning, the learning algorithm is not given examples of optimal outputs, but it must discover them by process of trial and error. Typically, there are a sequence of states and actions in which the learning algorithm is interacting with the environment. So here, we have some inputs are given, but kind of not as much inputs as will be given for supervised learning. So in many cases, the current action not only affects the immediate reward, but also has impact on the rewards of all subsequent steps. A general feature of reinforcement learning is the trade-off between exploration, in which the system tries new kind of actions to see how effectively they are, and exploitation, in which the system tries to make use of actions that are known to yield high reward. Too strong a focus on either exploration or exploitation will yield poor results. So they have a situation of trade-off. But to clarify it a bit, I think I have the next slide that explains a little bit more. For example, by using appropriate reinforcement learning techniques, a neural network can be trained to play a game to a high standard. So what are we talking about? The data set is in a series where one action yields another action, from one action to another action, gradually to the end. So we can say it's related to a time series kind of data. But I'm not going to spend so much time talking about reinforcement learning because this lecture is focused on supervised and unsupervised learning. So if you have some time, take some time to read about this. Example of semi-supervised learning or reinforcement learning is a credit assignment problem. So this is notations used to represent supervised and unsupervised learning. So in this case, we have xn, which is a d-dimensional real number, and we have yn, which is a real number, which is also a real number, right? So this is case of supervised learning. We have prediction, classification, and regression. Okay, so for here we have x, which is a d-dimensional real number from maybe from 1 to n. That is, it can't be 0, it can be an empty set of data. So here we have only x values, we don't have a corresponding y values. So here we also have probability distribution estimation, which is probability density estimation. We are trying to find association of features and dimensionality reduction, and so on and so forth. So try to read up this and try to understand differences between these classes of machine learning problems that we've talked about. So yeah, this is as well. So going back, this supervised, unsupervised, semi-supervised reinforcement, and so this is about the same thing we've done, and I'm going to just move on. So these other sites of machine learning, other set of problems that comes under each of the categories. Like for instance, clustering, we have spectral clustering, we have k-means clustering, we have k-means clustering, we have also hierarchical clustering, we have Gaussian mixture model for density estimation, graphical models. For dimensionality reduction, we have principal component analysis, we have factor analysis, we have singular value decomposition. So try to get used to all this, a number of all these terms as we move. Now, this is an illustration of difference between supervised, semi-supervised, and unsupervised. So in this case, we have initial data is given to you, and you are told these are the groupings of this data. So if you are given a new data set, for instance, a new data set or data point at this point, you simply know that this data point it belongs to the right line, the right data set. So let me see if I can take a pen and see if I can write something. So let's say we have, maybe I can just change the color to black. We have a data point given at this point. Sorry, let me point interruptions. Pen in color should be taken black. So let's say we have a data point at this point here. So how would you classify this data point? It will be kind of very easy. You classify it belonging to the right class. Okay, in this case, in this second case, if you are given a data point at this point, we'll have a problem because it doesn't belong to any cluster, right? So you have a problem here. In this case, it's easy. Classification tends to be easier than in this case of unsupervised learning. We have to do clustering. So you have to somehow find a way to assign this data point to one of these clusters. And we have semi-supervised learning. So in this case, we have a mix-up kind of supervised learning and unsupervised learning, where we have the groupings are done, but they are not completely done, right? So I'm going to move on at this point. So we have a case of neural network. Now, how does neural network what connection does neural network have with all of this? Well, neural network is simply a model of solving problem. Can apply neural network in solving any problem, whether supervised, unsupervised, or semi-supervised. So we can't say neural network belongs to supervised or it belongs to unsupervised. We can't do that. Neural network is simply a way to model data so that the model tries to behave like the human brain, right? So the origin of neural network is a way to find mathematical representation of our brain. trying to model how the brain works using mathematical notations. Sometimes this neural network, artificial neural network, make no mistake about it. So this is actually artificial neural network we are talking about. We are trying to, people try to say that they can build systems that actually thinks like human brain. The human brain is made up of, I'd like to just take the writing to write again on the screen so I can explain a bit more. Okay, so now this is how human brain is. They have this neuron. So let me just see. I don't know if I can draw it correctly. Okay, so we have a neuron. Let's say this is like how a neuron works. This is a brain is made up of thousands of these items called a neuron, and there's not thousands, maybe millions or billions, and they interact, sending data between themselves and interacting to send a signal between themselves. The more signal passes from one neuron to another, there is information that is passed, and also there is some kind of optimization that is passed from one as data move from one neuron to another in our brain. So that is what humans are trying to model by creating artificial neural network. Think of it as artificial brain system. From the perspective of practical application, achieving this will be kind of impossible. Achieving exactly how the brain works is kind of impossible because the brain, the way it works for now, has not even been understood by scientists. So we cannot actually model it completely in mathematical terms. So the focus is actually how to create a model to be efficient, that becomes efficient enough to be able to recognize images and perform some simple actions. So our attention is usually given to a specific class of neural network that is called multilayer perceptron. Now, when we discuss neural network in further lessons, it's going to become a little clearer. But I'm trying to just explain that neural network is a way to solve a problem, whether be it supervised learning problems or unsupervised learning problem. Solve a problem by trying to model the way biological systems work. So we have this example of neural network. So these are neurons, right? Think of it as neurons, and then we have inputs. It moves from one set of neuron to another. So these neurons are not placed haphazardly; they are arranged in layers. I have this layer where the data comes in. It's called the input layer. We have a layer in between. It's called the hidden layer because it's kind of hidden. From the input you can't see this layer. From the output you can't see this layer. Now the hidden layers can be many of them. There can be millions, thousands of hidden layers. And at the end we have the output layer. So basically what is inside our brain we don't know, but the actions we take, the output is what we know. So that is how the brain works. So whatever is in between is called the hidden layer, and they also, all of them are sites of neurons. All right, so I'm going to move on to the next thing. Now you may have also heard of deep learning. What is deep learning? How does it relate to supervised and unsupervised or semi-supervised learning? Deep learning is a subset of machine learning. In this case, the learning algorithm uses multiple layers to progressively extract higher level features of raw input. So deep learning is simply a more complicated kind of machine learning, and most times deep learning is implemented using neural networks, right? So when the network is become so complex, so many layers, thousands of layers, and perceptrons or neurons, thousands of them coming together, we now talk about deep learning. So there's nothing fancy about it, simply that it's a bit more complex than normal machine learning models, right? It can be applied to any of the learning tasks I mentioned. This is an important benefit because unlabeled data are more abundant than labeled data. So this blob here highlights the difference between AI, machine learning, and deep learning. So take some time to read it up and understand how it works. Also check out my website. You see quite explanation the difference between artificial intelligence, machine learning, and deep learning. Now, this is another thing I want you to know. Machine learning versus data science. Now, I think both of them have many things in common, but there's also some difference between the two you also need to know. I'm not going to spend time reading this, but I'd like to mention the similarity is that both of them study scientific methods, algorithms to extract knowledge from data and take actions or build intelligent systems, let's put it this way. And also both of them has to do with mathematics. But while data science has to do with theories, machine learning has to do with practice. So think of it as science and engineering. Data science is the science of machine learning, and machine learning is the engineering of machine learning. Think of it that way. So I move on. Now comes the practical aspect. So let's now go to practical 3 and let's actually do some work, right? Okay. So practical 3, according to our course outline, has to do with this is practical 3, data acquisition. We are going to be talking about online data repositories. We're talking about importing tabular data into Python, exporting data to Python, and getting some data for free from our libraries. So let's start with the first one, data acquisition or data set acquisition. Now, there are different sources of data. For instance, I found this Vincent RL bundle GitHub IO. It contains several data sets you can actually use for free to solve problems or to do your analysis or for your learning. We also have the UCI machine learning repository. You can also get some free data. We're actually going to go to these data sites at this point. So we can also get some data sites for free from our libraries in RStudio. And then we can also import tabular data into Python, export tabular data from Python into spreadsheets. Let's get started. So first, let's try to access this repository. So I'm going to just click on that link, and it takes me directly to the data site. So right now you can see many data sites. For each of the data sites, we have it in CSV. We also have the doc format that explains this data site. We also have some details, dimension about of this data site. For instance, let's take for instance the Acme data set contains 60 rows and 3 columns. I open the CSV so that you can see that these data sets, you can easily get them for free. So you can see this data set right here. Again, you can go to some data set that is more complex. For instance, we have this is 1,525 rows by 10 columns. It's car data. So I can just open the CSV as well. Just open it. I can see the CSV right here. Okay. So this is one way to get data sets. Now I'm going to save this data set in my system so that we can use it for the next part. So I'm going to just go to, let me just use the first one, Acme. I'm going to just right click on it and just say save target as, and then I'm going to save it in my drive D inside the data folder acme.csv. Perfect. So this is one way to get free data from a repository. And let's look at the next one. The next one is UCI machine learning repository. For many machine learning data scientists and machine learning experts, they always visit this repository. It contains whole lot of data sets that you can use to play around or you can use to practice. Again, I'm going to click on it and it's going to take us directly to this machine learning repository. So I have 481 data sets is maintained in this repository. So let's try to take one of these data sets. For instance, breast cancer, Wisconsin. I don't know about this data set, but let me just open it. And to get this data set, you simply go to the data folder and you can see all the data. Now, one thing you need to know is that you have the data set is in .data format. It's not a program. We can also import it, export and import it. Let's try to use this. You have unformatted .data. So let's go with this one. I'm going to right click. I'm just going to save target as, and I'm going to save it a breast cancer or Wisconsin.data. I'm going to save it right in my drive D, and I'm going to try to open it from my drive D data, and you can see this is saved as a text file. So if I open it, you can see, oh, it's opening somewhere else, right? So you can see it opens as a text file, as you can see. Okay, so how do we proceed from here? So again, I'm going to now, we are going to import it into Python, so don't worry about this. Let's now go to our presentation and see. Also, we can get data set from R libraries that I've demonstrated, but for the sake of completeness of this presentation, I'm going to go to R and try to get a data set as well. So let me just go to R. So R opens up in the RStudio environment. So what I'm going to do is to just go to, it takes a while. Okay, perfect. So I'm going to just go to packages. To packages, you can go to ISLR here, and you can see several data sets, and you can see a number of data sets. Now I'm going to just go to packages. If I click on ISLR and just click on install, and click and right here ISLR and just install it. I've installed it, so I'm not going to install again. So in ISLR, there are many data sets inside. So now I want to export this data set from R to my system. So I'm just going to say the college data set. I'm going to say write.csv, and I'm going to specify the name of the data set, college, and I want to specify the file I want to write it to. I want to write it into data, and I'm going to call it college.csv. So at this point, if I press enter, it's going to export this data to my folder. So if I come here, you can see we have college.csv. All right, so let's continue with our presentation. Now we have seen how to get free data sets. Now, how do we import this data set into Python and use it in Python? Let's see. Again, we have, so let's use the Pandas DataFrame. Now let's talk a little bit, a few seconds about Pandas DataFrame. To be able to work with data in Python, you need Pandas. Pandas is a module that you use to work with data. Now, Pandas call the data frame, and it's a way to represent data that is in a tabular format. The tabular data has rows and columns just like CSV files, and in order to read the data, you'll use pandas.read_CSV. This function will take the CSV file and then return the data frame. So let me see if we have examples. Okay, no. So let's do a demo to read the college data set we just exported from R. We are going to read it into Python. So at this point, let me just clear the screen. So I'm going to just say, get to the next, okay, here. So what I'm going to do is to read the college data, and I'm going to say, first I need to import pandas. I don't know if I've done it. Import pandas as PD. And I'm going to say pd.read_CSV. Now, if I'm reading this data, I want to assign it to a new data frame. So I'm going to call it college data equal to pd.read_CSV, and I'm going to assign it to assign to college data frame, and I need to specify the path to this file I want to read. So D is going to be data and it's going to be college CSV at this point. So you can see, so I need to take all these. So if I run this cell, it reads this data. So if I look at it, college data, actually I can say college, okay, just say college data. So it actually read this data, and you can see we have this data right here, as you can see. So it's quite a large amount of data here. So that is how to read data from an external file. But we also have this .data file that we have here. So we have .data. Let's see. Yeah, this .data. So let me try to read this file as well. So this time, instead of saying dot read CSV, I think we can say read underscore table. So I'm going to say, let me just call it cancer data is equal to pd.read underscore table, and specify the location of the data set, data, and I think the name I copied to my clipboard .data. So I've done, okay, I think I've tried this before, but let me do it this time and see what we have. Okay, it actually read this data. So in as much as is .data format, in this case you use the syntax pd.read underscore table. In this way you can read any other format. So if I check cancer data, and let's see what we have, ironic. So at this point, the data is not well formatted. So I'm going to just say at this point, I'm going to say sep equal to comma. So I'm trying to tell Pandas that this data is separated with comma. I'm going to just run it and run again. So you can see this is exactly what we expect from the data, okay? All right, so later I'm going to show you how to add header to this data, because this is actually the first row and not a header. Okay, so let's move on to the next part. Let's take this out. Okay, so we've done this. Now, DataFrame head, tail, and shape method. So to view the first 5 rows, you use the head. To see the last 5 rows, because a data set can have thousands of rows. So you want to see the last one, you want to see the first part of the data set, you can use head and tail. I'm going to just go and demonstrate it as well here. So let's say we have, I can just say cancer data dot head. So it will display the first 5 rows, and cancer data dot tail is going to display the last 5 rows of this data. So you can see row 693 to 697, and let's see cancer data dot shape. Shape shows the dimension of this data, the number of rows and columns. I think it works this way, so I'm going to just, so 698 rows by 11 columns. Okay. All right, so we also have indexing Pandas DataFrame. How do you select slices of data from Pandas? They use the iloc method. Iloc retrieve rows and columns by position. In order to do that, we need to specify the position of the rows we want and the positions of the columns we want. So at this point we have this. I would like you to play around with this, but let me demonstrate what iloc is doing. So let's say you want to select row 20 to 25. So you simply say, let me get back to just to check. So you simply say cancer data dot iloc, and you specify the rows, which is 20 to 25, and then 20 to 25, and then you don't specify any columns, so it's going to select all the columns from row 20 to 25 is selecting all the columns. So let me just write a little comment. So how to do it is you say iloc. The first thing you specify is row range, comma, column range. All right. So if we want to select columns 20 to 25, row 20 to 25, but we only want to select 3 columns. So in that way, you can say cancer data.iloc, and we specify row 20 to 25, comma, columns 1 to 3, columns 1 to 3. Right? So this way you are selecting subset of your data. So this is how to select subsets of data. All right. So actually so that is how it works. So 1, 2, 3, 4, 5. Okay. So this 1, 2, 3. So it's going to give us 2. So what are we saying? If you specify a range, the last last limit of the range is not inclusive. So it only selects row 1 and 2. Also, in this case, it selects 20 to 24. So make no mistake about it. I've also actually confused this sometimes. So if you want to select row 1, columns 1 to 3, we actually specify 1 to 4. We're actually going to learn about this more when we will be talking about working with Python using PyCharm, and that should be module 4 or something like that. So I'm going to just run it, and now we have 3 columns. All right. So let's check where we are at this point. So try to play around with this. Now, reviews is the name of the data frame. You need to replace these reviews with the name of your own data frame and see how it works. If you don't specify something, then the first item is assumed. What do we mean? So at this point, if I don't specify, 20, it's going to assume you are starting from the first one, right? So if I run it at this point, it selects from the first row, okay? So this is also clear from my presentation at this point. So let's see where we are. Outputting data to CSV. Now, remember we have this data we imported into Python that is .data. Now, how do we export it now to .csv and work with it? So I'm going to show you how to do that. You use df or dataframe.toCSV. So at this point, we have this. I'm going to say cancer data dot to underscore CSV. I think I'm getting it, so let me just verify. Dot to underscore CSV, and I'm going to specify the name of the file I want to import it into. So data cancer data.csv. So I'm going to run and let's see. Okay, so we've exported this data that was in .data format now to a CSV format. So if I go back to my folder, you can see this cancer data.csv that we already had it in .data. Now we have it in .csv. Isn't that amazing, right? So this is how to export data to a .csv file in Pandas. So try to play around it. All the procedures are in this presentation. And please take your time to follow along and make sure you understand it. Writing data to Excel. In this case, you simply say data.write.excel writer. Now I'm going to also demonstrate this one as well because it's important. You may want to work with an Excel file. So let's write to Excel. So we want to export instead of to CSV, we export to Excel. So it's a cancer data. Okay, so you have to create a writer first. Writer is equal to pd.excel writer, and you specify the name of the file you want to export. So d slash data slash cancel data dot x x, okay, and then I'm going to say excel df.toExcel and specify the writer and the data frame. So cancel data dot to underscore excel and specify the writer and specify the name of the data frame. In this case is cancel data. I think I'm getting it. Let me see. Okay, so writer.save. So I actually have not done this, but let's run it to see. Okay, so hopefully we have the file now created for us in Excel format. So we can see cancel data.excel. So it's not too much different from what we already have before now. All right, so this data frame is name of the sheets. So here we specify the name of the sheets. So this is going to be the name of the sheet. So this is how we come to the end of this class. I hope this has been informative for you, and the next class we actually start going into a bit of machine learning or supervised learning. We are going to be talking about linear regression in module 5. So I'd like to thank you for viewing. I'd like to recommend you make sure you do all the exercises, make sure you follow all the procedures, and if you have challenges, feel free to let me know. And we see you in the next module.